Yes, welcome back. Now let us solve fifth example based on variable separable method. Here the fifth example we are going to solve second order partial differential equation. Okay. See here, solve dou square u by dou x square is equals to dou u by dou y plus 2u in the form of u of f of x into g of y. Obtain the solution satisfying u is equals to 0, dou u by dou x is equals to 1 plus e power minus 3y when x is equals to 0 for all values of y. See, this is the second order differential equation because it is the double derivative LHS side dou square u by dou x square. Therefore, it is a second order differential equation, and here u is the dependent variable and x and y are the independent variables. Now let us solve second order differential equation. Okay, it is somewhat different from first order differential equations. Okay, and you need to concentrate on the given condition. Given condition is u is equals to 0. Okay, u is nothing but solution dependent variable value is 0, and dou u by dou x first derivative value is with respect to x is 1 plus e power minus 3y when x is equals to 0. This is the given condition. Okay, now the given differential equation you take it as 1, and the given condition you take it as equation 2. Okay, so equation 2 is equation 2 represents the given condition u value 0, dou u by dou x value 1 plus e power minus 3y when x is equals to 0 and for all values of y. Okay, so you please remember this condition, second condition. Now let us proceed as usual. So the dependent variable is u and independent variables are x and y. Now let us write the solution. U of x comma y is equals to x of x into y of y. Take it as equation 3. Be the solution of 1. Now here we need the value of dou square u by dou x square and the value of dou u by dou y. Now let us differentiate equation 3 2 times with respect to x, and let us differentiate equation 3 one time with respect to y. So if you differentiate 2 times with respect to x partially, you are getting dou square u by dou x square is equals to x double dash of x. Okay, x double dash of x into y of y. Y of y is constant. Take it as equation 4. One time you differentiate equation 3 with respect to y partially. Therefore, dou u by dou y is equals to y dash of y into x of x. You take it as equation 5. Substitute equation 4 and 5 and equation 3 in equation 1. So in place of dou square u by dou x square, you are writing equation 4. In place of dou u by dou y, you are using equation 5. In place of u, you are writing equation 3. Okay, then if you substitute all these in equation 1, then your equation 1 becomes x double dash of x into y of y is equals to y dash of y into x of x plus 2 into x of x into y of y. Okay, now let us rewrite these expressions. This last term you take it to LHS side, it becomes x double dash of x into y of y minus 2 into x of x into y of y is equals to y dash of y into x of x. Here in these two terms you take x of x common, y of y common. Therefore, x double dash of x minus 2 into x of x into y of y is equals to y dash of y into x of x. Now you separate the variables. X double dash of x minus 2 into x of x divided by, send this x of x to LHS side, it will come in the denominator, and send y of y to RHS side. Therefore, RHS side you are getting y dash of y by y of y. So here this is completely, LHS is completely function of x, RHS is completely function of y. Means your ODE converted into PDE. Your PDE is converted into ODE here. Okay, you got two differential equation. One is with respect to x, one is with respect to y. Okay, now equate these differential equation to some constant lambda. Okay, now we need to solve this. Okay, first you take the first differential equation. x double dash of x minus 2 into x of x divided by x of x is equals to lambda. Okay, then you rewrite, send this denominator part to RHS side. It becomes x double dash of x minus 2 into x of x is equals to lambda into x of x. Take lambda into x of x to LHS side. It becomes x double dash of x minus 2 into x of x minus lambda into x of x is equals to 0. Then here x of x is common in these two terms. If you take x of x common, then the remaining term is x double dash of x as it is, minus you take it outside, so the remaining term is 2 plus lambda into x of x is equals to 0. So if you see clearly, take it as equation star because it is a quadratic equation. So if you solve this quadratic equation, that is nothing but ordinary differential equation you are solving here. You know that while solving ordinary differential equation of second order, you are taking auxiliary equation. Okay, auxiliary equation of equation star is auxiliary equation, always you are writing in terms of m, right? Here x double dash of x, in place of x double dash of x we can write m square minus 2 plus lambda is equals to 0 is the auxiliary equation of equation star. Okay, then if you solve this, m square is equals to 2 plus lambda, m is equals to plus or minus square root of lambda plus 2. So means here you are getting two roots. Okay, one is plus square root of lambda plus 2, second root minus square root of lambda plus 2. Therefore here the roots are real and distinct. Whenever you are getting real and distinct, therefore your general solution is, so you just remember the concept of ordinary differential equation. Whenever you are solving by taking auxiliary equation, you are getting roots of the equation. If the roots are real and distinct, therefore the general equation is x of x equals to c1 into e power x plus c2 into e power minus x. Here c1 into e power x, in place of x use here the root, first root, square root of lambda plus 2 into x plus c2 into e power minus x. E power minus root is lambda plus 2, square root of lambda plus 2 into x. So this is the solution, x of x. Okay, you take it as equation 6. Now let us solve one more ordinary differential equation, y dash of y divided by y of y is equals to lambda. Integrate it on both sides, okay, with respect to y. Therefore you are getting log y of y is equals to lambda y plus c3. Okay, then send log term to RHS side. Y of y is equals to e power lambda y plus c3. Split this exponential term. Y of y is equals to e power lambda y into e power c3. In place of e power c3, use the notation capital C. Therefore y of y is equals to capital C into e power lambda y is the second solution. Now you got two solutions, x of x value, y of y values. Now use these equations 6 and 7. Okay, use equation 6 and 7 in equation 3. Then your equation 3 is u of x comma y is equals to x of x into y of y. Then if you substitute equation 6 and 7 in 3, you are getting u of x comma y is equals to x of x value c1 into e power square root of lambda plus 2 into x plus c2 into e power minus square root of lambda plus 2 into x into e power lambda y. So equation from equation 7, c into e power lambda y. Just you are writing e power lambda y because here the constant c is absorbed in c1 and c2. Okay, so here c1 and constant c1 and c2 covers c. Therefore no need to write this c. So we can write this c is absorbed in c1 and c2. Okay, therefore this is the solution, complete solution. But here it contains lambda, right? It contains lambda and two constant. Now again we need to solve because they are given some conditions. Okay, so the given condition is dou u by dou x is equals to 1 plus e power minus 3y for x is equals to 0 for all y. Here you need to remember here two conditions there. One condition they are given, dou u by dou x is equals to 1 plus e power minus 3y. This 1 can be written as e power 0 into y, right? This 1 can be written as e power 0 into y. Means here let us assume here e power 0y, e power minus 3y. Again e power 0y, e power minus 3y means directly here you are getting 2 lambda values. So 2 lambda values, 1 is equals to this 1, you can first term of this 1 is equals to e power 0y. Therefore choose lambda is equals to 0. Okay. Then similarly second term is e power minus 3y. Now you choose lambda value minus 3. Then again we are solving the equations by using these 2 lambda values. Now we are going to make 2 cases. When lambda is equals to 0, what is your solution, and when lambda is equals to minus 3, what is your solution? Okay. Then let us consider first case. When lambda is equals to 0, okay, your equation 8 becomes u1 of x comma y, because case 1, so that you are you better to take it as u1 of x comma y is equals to c1 into wherever lambda is there you just substitute 0. Therefore your last term becomes e power 0 into y. E power 0 value is 1. Therefore you are getting c1 into e power root 2x plus c2 into e power minus root 2x. So in place of x, use the new condition. So from the given condition, they are given one more condition. You just revise from equation 2. So u value is 0 when x is equals to 0. This is the first condition. If we use u is equals to 0 and x is equals to 0 in equation double star, then u is equals to 0 means your LHS side becomes 0, and in place of x if you substitute 0, e power 0 and e power 0. Therefore you are getting c1 plus c2 is equals to 0. You take it as equation 9. Then differentiate equation double star with respect to x. This is your equation double star, okay, after substituting lambda value. So this equation double star you differentiate with respect to x. Therefore you are getting dou u1 by dou x is equals to, so differentiation of e power root x, e power square root of 2 into x gives c1 into square root of 2 into e power 2x, e power square root of 2 into x, and here differentiation of e power minus square root of 2 into x gives minus square root of 2 into minus c2 into square root of 2 into e power minus square root of 2 into x. Okay. Then after differentiation, just you take square root of 2 as common, then dou u1 by dou x is equals to square root of 2 if you take outside, c1 into e power square root of 2 into x minus c2 into e power square root of 2 into x. Then here let us use the condition when x is equals to 0 again. So when you are substituting x is equals to 0 here, okay, you are getting RHS side e power 0, here also e power 0. Therefore square root of 2 into c1 minus c2. And here we are solving for the first case when lambda is equals to 0. When lambda is equals to 0, you see here first derivative value. So first derivative value means first notation, dou u by dou x value is 1 here when lambda is equals to 0. Therefore this is the first case. Here in place of dou u by dou x, let us use 1, okay, because first case we are solving when lambda is equals to 0. So lambda is equals to 0 means use 1 in place of dou u by dou x. Therefore your expression becomes, in place of dou u1 by dou x you are using 1 is equals to square root of 2 into c1 minus c2. Therefore if you rewrite this, c1 minus c2 is equals to 1 by square root of 2. This is your equation 10. So here you got equation 9. Equation 9 is c1 plus c2 is equals to 0, and equation 10 is c1 minus c2 is equals to 1 by root 2. You solve equation 9 and 10, so that you are getting c1 and c2 values. Equation 9 is c1 plus c2 is equals to 0. Equation 10 is c1 minus c2 is equals to 1 by square root of 2. So plus c2 minus c2 cancels. If you add it, 2c1 is equals to 1 by square root of 2. c1 value is 1 by 2 into square root of 2. So use this c1 value in equation 9, so that you are getting c2 value. c2 value minus 1 by 2 into square root of 2. Now use this c1 and c2 values in equation double star. Therefore your equation double star becomes u1 of x comma y is equals to 1 by 2 into square root of 2 e power square root of 2 into x plus in bracket, if you use c2 value is minus 1 by 2 into square root of 2 into e power minus square root of 2 into x. This is your equation double star after substituting c1 and c2 values. So then here you multiply, plus into minus gives minus sign. Then you take 1 by square root 2 is common in both the terms. If you take 1 by square root 2 outside, then you are getting e power square root of 2 into x minus e power minus square root of 2 into x divided by 2. Here you know value of this sin hx can be written as e power x minus e power minus x by 2. Using this formula, in place of e power x minus e power minus x by 2, we can use sin hx. So sin hx means in place of x we are having square root of 2 into x. So therefore we can write u1 of x comma y is equals to 1 by square root of 2 as it is. Then in place of this we can by using this formula we can write sin h x means square root of 2 into x. This is the first solution. This one you take it as equation 11. Okay, so this is the first part by considering first lambda value, that is lambda is equals to 0, I think, right? So when lambda is equals to 0, yes, this is the first result you got, and this is the solution. You name it as u1. Now let us go with the second case by taking lambda is equals to minus 3. Okay, so lambda is equals to minus 3. You substitute again in equation 8. So your equation 8 becomes, here now let us take the notation u2, because second part of solution, u2 of x comma y is equals to c1 into e power lambda value minus 3. If you substitute here, you are getting e power minus square root of minus 1 into x plus c2 into e power minus of square root of minus 1 into x e power minus 3 into y. You take it as equation triple star. So you solve like case 1 how we solved, you just follow the same procedure here. Then here you know that one result e power ix can be written as cos x plus I sin x. So here square root of minus 1 is nothing but I. So from complex number we know here I value is square root of minus 1, I square value is minus 1. So in place of square root of minus 1 we can write I. Here also in case of square root of minus 1 we can write I. Therefore here first term contains e power ix, second term contains e power minus ix. By using these two relations, e power ix can be written as cos x plus I sin x, e power minus ix can be written as cos x minus I sin x. So use these two results here. Therefore you are getting okay, let us simplify this. Okay, here I simplified by taking this term c1 into e power ix plus c2 into e power minus ix. So in place of e power ix you are writing cos x plus I sin x. In place of e power minus ix you are writing cos x minus I sin x. Now you multiply c1 into cos x plus I sin I c1 into sin x plus c2 into this term, that is c2 into cos x minus I into c2 sin x. Now from these two terms you take cos x common, therefore you are getting c1 plus c2. From these two terms you take sin x common, therefore you are getting sin x and I you take it as common, therefore c1 minus c2. Here you take the notation in place of c1 and c2, c1 plus c2, use the notation a. In place of I into c1 minus c2, use notation b. Therefore your expression reduces to a cos x plus b sin x. Therefore in place of c1 into e power ix plus c2 into e power minus ix, I can use directly a cos x plus b sin x. Okay, so here a cos x plus b sin x into e power minus 3y. So this is your u2 value. Now let us proceed as usual. The given condition, first condition is u is equals to 0 when x is equals to 0. Here if you substitute u is equals to 0, LHS side u becomes 0, RHS side wherever x is there, if you substitute 0, cos 0 value is 1, therefore a is equals to 0, sin 0 is 0, you know. Then a value is 0 here. Then again let us use this a value, substituting a value in above equation, in equation star, then your equation triple star equation star reduces to u2 of x comma y is equals to, here a value is 0, if you substitute you are getting b sin x e power minus 3y. you take this expression as equation 4 star. Okay, then you differentiate equation 4 star with respect to x. Dou u by dou x is equals to b, differentiation of sin x is cos x e power minus 3y. Now use the second condition. Second condition is in the given condition, dou u by dou x value is e power minus 3y when lambda value is minus 3. So because we are solving the second case by taking lambda is equals to minus 3, therefore here in place of dou u by dou x, let us use e power minus 3y. Therefore in place of dou u2 by dou x, you are getting e power minus 3y is equals to b into e power minus 3y. Okay, because cos 0 value is 1, you are getting b into e power minus 3y. So therefore LHS side e power minus 3y, RHS side b into e power minus 3y. So here e power minus 3y, e power minus 3y cancels, you are getting b value 1. Okay, a value is 0, b value is 1. Then using b value in equation 4 star, you are getting u2 of x comma y is equals to sin x, b value is 1, therefore sin x into e power minus 3y. You take it as equation 12. Okay, this is your equation 12 represents second part solution. Okay, so then you combine first part solution and second part solution, that is u1 value and u2 value together. If you write u1 of x comma y is equals to, so this is your u1 value, 1 by square root of 2 sin h square root of 2 into x, plus u2 value is sin x into e power minus 3y. So this is the complete solution of given second order partial differential equation. So I hope you understood. So if you get any doubts, you can contact me. So I explained till now 5 problems related to variable separable method, and you try to solve these practice problems. So here I given you 5 more problems for you. Okay, so you please try to solve these problems. If you get any problems, you please try to contact me. So okay, thank you for watching these videos. Thank you.